Hi everyone, I'm Carl Shepherd, the Data Jiu-Jitsu guy, and today I'm going to talk to you about the modern data warehouse. Before we get into the content, I'd just like to give you a quick introduction. I have over 15 years experience within the data industry. I started out as a business intelligence developer and I've worked in a variety of different data roles, and I currently work as a data architect. This video is part 3 of a 4-part series where I discuss the journey the data industry has been on over the last 20 years. If you haven't watched parts 1 and parts 2, I'd strongly suggest that you pause the video and go back and watch these, as I'll be making reference to them throughout. This series is aimed at anyone with an interest in data, and I will aim to keep it simple so that everyone can understand. Data is becoming an increasingly essential topic for everyone to understand, and is no longer just for data professionals. So first of all, here's the agenda. To begin with, I'll take you through what is a modern data warehouse, and then why you would want to use a modern data warehouse. Then I'll compare the traditional data warehouse, which I've abbreviated to DW here, and the traditional data lake against the modern data warehouse. Then we'll have a look at how this works in reality. And then finally, we'll do a summary and some next steps. So first of all, what is a modern data warehouse? A modern data warehouse allows you to realize the benefits of both the data warehouse and the data lake to gain insights through dashboards, reports, or advanced analytics. It also aims to reduce the separation between the traditional data warehouse and data lake by combining them into a single architecture. And for those of you that are more visual learners, I think this diagram that was done within a blog post that was done by Advancing Analytics, which are, for those of you who don't know, it's a consultancy firm based in the UK. And I think this diagram demonstrates the modern data warehouse nicely. So first of all, you've got your sources of information, and this all lands into what's called your raw area of your data lake. It can then move through into a clean area, which can then be used for prototyping and analysis by data scientists and data analysts. And this is typically where you do your predictive and prescriptive analytics as well. And then for anything that you'd like to do descriptive and diagnostic analytics on, you will then move that over into this warehouse zone. And then finally, you've got Power BI here, which is doesn't have to be Power BI, but Power BI is a Microsoft tool for creating dashboards and reports. It's very popular as well. So this is like your data lake zone, and this is your data warehouse zone. And this, like I say, this diagram shows how that combines together quite nicely. So if you'd like to go into a bit more of a technical deep dive, I'd strongly suggest going to the Advancing Analytics blog that I mentioned earlier, which is where I took the diagram from. That gives you some really good background on what a modern data warehouse is. And also Databricks and Microsoft, which are two of the big vendors in this space. They both give a nice description on what a modern data warehouse is. So why would you actually want to use a modern data warehouse? A modern data warehouse provides a single architecture to handle all analytical use cases. If you remember in parts 1 and part 2, where we discussed the data warehouse and data lake, those were often treated as very separate entities, whereas a modern data warehouse aims to bring that all together in one place. It also scales to hold all data in the data lake area just in case, and takes advantage of low-cost storage. It then allows you to only bring through the data that's required for descriptive and diagnostic analytics into that data warehouse database layer. And this is typically more expensive to store data in. It also allows you to do data exploration within the data lake area to see what data is valuable. And it can act as a requirements gathering phase for what goes into the data warehouse database layer. And in certain scenarios, you can aggregate data in the data lake before bringing it into the data warehouse database layer. And this enables you to optimize cost and performance. And this bottom one, I think, is the most important. And what I believe the modern data warehouse does is that it gives you all the benefits of the data warehouse and data lake combined. So now we're going to discuss the traditional data warehouse, the data lake, and how that compares to a modern data warehouse. So if you remember from part one and part two, where we discussed the data warehouse and the data lake, there was a very clear separation between the two in the early days and in the early stage of this being popularized. Um, so we use the data warehouse for the descriptive and diagnostic analytics. So that's what happened and why did it happen. And as we mentioned, the data warehouse is in a very defined structure. And then the data lake, which is a lot more free form and you can store the data as is. This is where you do your predictive analytics and your prescriptive analytics. And as I mentioned, there was a very, very clear separation between the two to begin with. And even to the point where some, different teams might look after the data warehouse and the data lake. Now, if you compare that to the modern data warehouse, this combines the data warehouse and data lake together into a single place. Now, to begin with, what you start with is you extract all the data from your different source systems and load that into the raw area of the data lake zone. You can then run some transformations and put this into the clean area. And this is where you can do your prototyping and analysis, but it also this is the zone where the data scientists would build their machine learning models for predicting what might happen and also prescribing what actions should be taken. This clean area then provides is the source for the data warehouse zone. So this is like almost like your traditional data warehouse that we talked about, where it's got like your predefined structure. And then this would then enable you to do your descriptive and your diagnostic analytics. So you look at what happened and also why it actually happened. So again, just to go through some more comparisons between the three products, the modern data warehouse started to blur the lines between having a clear separation between a data warehouse and a data lake, which was a big step forward. It also allows you to take a bottom-up approach with your data warehouse. Um, if you remember from the first video, the data warehouse took a bit more of a top-down approach where you decided what data would be useful and then brought that through into your data warehouse. Whereas with a bottom-up approach, it allows you to almost gather your requirements at that lake level by doing your prototyping and analysis there. Data lakes also no longer become data swamps, as the modern data warehouse requires structure in order for it to work correctly. The data warehouse is still slower to build than the data lake area, but this is an acceptable trade-off as people still get fast access to data in that data lake zone that we talked about. And certain data assets are still copied in both the lake and the warehouse, but the benefits of this outweigh the drawbacks. So now, how does this work in reality? So to begin with, a business decides to invest in a modern data warehouse to help them solve all analytical needs in a single architecture. A data engineer can then work with a business to establish what data is required and will also collect more data than is required to be on the safe side. Like we talked about earlier, with the data lake, you collect data just in case. A data engineer extracts the data required and loads it into the raw area of the data lake. And this is the extract and load part of the ELT that we talked about. A data engineer can then transform the data required and load it into the clean area of the data lake. And this is obviously the transform part of ELT. A data scientist can then use the clean area of the data lake to perform some form of predictive or prescriptive analytics. And then the next step could be a data engineer can load data from the clean zone into the warehouse zone, which is the data warehouse. Now, it's worth pointing out here as well is that the clean zone will always contain more data than the warehouse. So the clean zone is, like I say, is where you would do your predictive or your prescriptive analytics, and the warehouse would specifically be for your descriptive and your diagnostic analytics. And then finally, a data analyst can use the data warehouse to perform some form of descriptive or diagnostic analytics. So just to bring this to life, I thought we'd do the same example that we've worked with in part one and part two, and that's the example of an airline. So we start with the decision, and a decision is made that the business would like to create a modern data warehouse, and their priority is to look at ticket sales and customer information. Then you've got the development phase. The data engineer extracts and loads the appropriate data required into the data lake area of the modern data warehouse on a one-off basis. In the analytics phase, a data analyst can explore the data to see what is valuable through prototyping and analysis. They build a prototype customer ticket sales dashboard for end users to consume. And then the insight from this analytics is that the end user and data analysts feel like that this dashboard would be useful for people to use daily to track performance. And then the action here is that the data analyst can then work with the data engineers to bring through the appropriate data via the ELT processes into that data warehouse layer so that the data analyst can build the dashboard with information that is updated daily. So to summarize, at the time of recording, modern data warehouses are probably still the most common way for data platforms to be built. Organizations realized that having a clear separation between the data lake and the data warehouse was not optimal. I hope that I've been able to demonstrate to you that the modern data warehouse can solve all of your analytical needs within a single architecture. And part 4 in this series, and the final step in the journey, we will cover the data lakehouse, where the differentiation between the data warehouse and data lake all but disappears. The data lakehouse aims to enhance the modern data warehouse further and combine all of the best features of the modern data warehouse and minimize the downside. Thank you very much for listening. If you've enjoyed this video, then please like and subscribe to my channel. And if you have any questions or comments, then feel free to add them to the comment section below. Thank you very much.